Welcome back, guys. We're just doing another little video to help you with a exercise out of the textbook. Now we're doing something called prime decomposition. We're taking a number and we're decomposing it into its prime factors. Now that's important because if it's a composite number, a lot of those numbers can be built multiple different ways. And because they have multiple factors, right? But every number has a unique combination of prime factors. It's almost like a DNA code for that number. Now, it's our job to break down that number into its prime factors, and we might have to use and hopefully we will use these little smaller numbers to help tidy things up. If, for example, if we've got 2 times 2 times 2, instead of writing that out nice and long, we might shorten that to 2 to the power of 3. Okay, so that's the work that we need to do, and I'm going to get behind the light board here and give you some examples to work through. And my advice here right now is you have your pen and paper out. As I'm writing, you're also writing. Now what we're working on is prime decomposition. Okay, hopefully you can see that word in here, decompose. We don't mean it in the sense that the numbers are breaking down and smelling bad or something like that. We mean that these primes can be broken down into any number can be broken down into prime factors. And all numbers, this is what I want you to hang on to, all numbers can be written as a product of prime factors. So when you see this word products, we think about the times sign, and we're going to write all this with the times sign between it. Now, I really like this because we're bringing together a bunch of skills on primes, factors, powers, and indices. So we're going to draw some tree diagrams. We put the number at the top, for example, and we try it out on each of the branches. As we make a fork, we try to put a prime number on those branches, and then it's an easy job to read them off. However that looks, that's okay. People will see different things, and I'm just going to show you a nice, neat way, I think, to do some of this work. And I'm just going to begin with 90, and I might do that up the top here. I'm thinking about this as, I'm thinking about my primes. I'm thinking 3 is a nice number to use because that goes in 30 times. And again, I'm going to drag that 3 out of the front because 3 times 10 is 30. And finally, 2 times 5. Now they're all primes. You can circle them if you want, and then we just need to write a statement underneath, and this is what I write 90 equals, and I try to put things in ascending order. It's kind of like tidying things up. You can check that on the calculator and work out that that equals 90, and then finally we can do a tidy up step again, because we can use our index laws here and write this as 2 times 3 to the power of 2 times 5. And this is like the DNA for 90. This is how 90 is constructed. Okay? So, interestingly, what does that look like? What does 90 look like if we had to build it using these instructions? So, I'm seeing 3 times 3 is 9. Okay, now I could make a row of 5, So I've got 3 squared, 3 times 3, and I've got them in a row of 5, and that there's equal to 45. And this final part of the instruction, well, why don't I just put in another row of exactly the same, double everything up, and suddenly, what do I have? I have 2 lots of 45, and that's equal to 90. Add them together, we've got 90. All right, so that is the unique way, or the unique DNA for 90. Okay, it is built, 90 is built using 3 by 3 squares. Okay, and we need 10 of them. I could have put them all out as a single row, but I'm just trying to get you to think about dimensionally, what does 90 look like and how could you build it? Now let's try another number. I want to try 56, and I like this because it's an even number, and this is a trick we can employ with even numbers. We can always halve them. 2 is prime and 2 is an easy number to work with, and we can just think about halving 56 here. Half, I'm thinking about it this way, half of 50 and half of 6, and that's going to be 25 plus 3. That's going to be 28. Okay, it's an even number again, so let's do the same thing. And I end up with an even number again. And this time, 2 times 7 is our prime factors. They're all prime numbers on all the branches. If you want to circle them, you're most welcome to double check that they're all prime. And then finally write a statement. 56 is equal to 2 times 2 times 2 times 7. And then do the tidy up work. This is a tidy up step. We can use our index laws here, and we can write this as 2 to the power of 3 times 7. Okay, so that's what our final answer looks like, and that's kind of how I want you to set out the work. So what I might do now for you is just do one more. So I'll just quickly get rid of this work here, and let's do one more. So let's have a look at this. Let's choose a bigger number, 220. It's nice and even, and I'm going to employ the same strategy here. 2 times 110, and something's going to happen here. I'm looking at 11 is prime, and times that by 10, and suddenly we're starting to understand 2 times 5 is 10. That's easy. I always look at 10 like this. 2 times 5, and that's 10. So we've got everything we need. 220 is equal to 2 times 2 times 5 times 11, and just the final tidy up step, and we've got 2 to the power of 2 times 5 times 11, and they're all prime factors multiplied together. So 200, what we say is 220 is the product of 2 to the power of 2 times 5 times 11. Okay,